Hello, everybody. Hello. 10:21. We got time for a video. Today is contains duplicate number 2. I've never solved this before, so let's do this. Given an integer array nums and an integer k, return true if they are two distinct indices I and j in the array, such that nums of I and nums of j equals and their difference is less than or equal to k. Okay. That looks pretty straightforward, to be honest. Yeah, it's pretty. Can I just do this, Nums. We gotta start here. Okay, now actually this is a bit complicated. Because I could do. Is this sorted? What if I sort it? Given an integer array nums and an integer k, return true if there are two distinct indices n, I, and j in the array, such that nums of I equal j, and their difference is less than or equal to k. I don't think it's sorted, so I can't use that 2 pointers. How does a sliding window work here? I actually don't get how a sliding window works here. How is this sliding window? Ooh. Maybe some kind of hashing, hash map, So let's plan this out a bit more. Right. So if I get the frequency of everything here, right? So if you do like 1 appears 1 time or twice, 2 appears once, 3 appears once, and that's the building of the list or the dictionary. And then we can go through it. Wait, I feel like you can just do this with less memory too. Okay, let me just try this. It's 2-pointer method, right? For I are in range of length of nums, right? And we just start 1 and right, and nums of R. Simulate this. Right? ABS. This if nums of, or if L, if nums of R equals nums of L, and then wait, this is wrong. R minus L. Then This is weird as fuck. I actually don't get how this works. How does sliding window work here? Oh, I guess the window is 2. Right? Ooh, I see. Right? So let me do this again. Like, the window is at first minimum 2. Right? So it'll be the first 2. Right? Let's do 1, 2, 3, 1. And then we'll say L is here, R is here. Test it out. So is this true? Nope. So increase. Is this true? Nope. Is this true? Yes. Because 3 minus 0 is 3 is less than or equal to k. Yes, that's valid. Okay, now let's try a different one. Let's do 1, 0, 1, 1. So we try here. Here, nope. Yes, they're identical. So yes, okay. But what about this one right here? 1, 2, 3, 1, 2, 3. We have L, R. So we try this. Nope. Nope. Ooh, try here. Put these together. So yes, but let's see. 0, 1, 2, 3. So 3 minus 0 is 3. So is that greater than or equal to 2? No. So we actually increase L. Shrink our window. Yep, and then move on here. Try this. Try these two. Nope. Let's try this. Nope. So let's move on. Try this. Yes. Nope. So nope. So we increase here. Put this here. Yes. Nope. So I think we increase L if ABS of R minus L is greater than K. How does that sound? I don't know if that makes sense. But if L or if nums of R equals nums of L, and R minus L less than or equal to K, AB, ABS, then return true. Otherwise, increase L. Just work, bro. I'm so tired today. Ha 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 ha. I think that should work. I don't think it is. Oh, close. Okay. let's see. So first two, nope. So are these identical? Nope. Is r minus greater than k? No. Wait, what? Is 1 minus 0 is greater than 1? No. So don't increase. Okay. So now we're at 2 and 0. Yes, they're equal. 2 minus 0 is less than or equal to 2 or 1? No. Okay, so we go here. Is 2 minus 1, 2 minus 0 greater than k? Yes, so increase L. So we increase L. So now we're at here and here. Oh, maybe this should be here. While does not equal L. How does that work? No. What about this? Ooh. Come on, please, 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 please. That would have been so cool, bruh. Alright, so let's see why this is the case. Should be false. Let's see. So we go in. It's gonna be 1 and 2. Let's see this. 2 is a 1 minus 0 is greater than. Oh wait, k equals 0. That's literally impossible. If k equals 0, return false. Yeah, it's literally impossible to have a situation like that. What kind of test cases these, bruh? Oh, come on, man. I know I'm close here. So like 58 and 64. So let's trace this one. So k is not that. So we got this. So we go from 1 minus 0 is greater than k. No. 1 is not greater than k. So then we check. Are these the same? No. Keep going till we find a match. Oh shit. What if we never find a match? Yeah, that's a bad fucking thing I didn't consider. So like we go here and we just never find a number. Damn. Yeah, that sucks. What if I sort the list so I can like ensure it? But that sucks kind of complexity wise. Damn, bro, I don't know about this test case here. So we go 0, 1, 2, 3, 1, 2, 3, 2, 5, right? if I do this? Alright, this is my test case that I don't know how to fix. So we go through, right? We basically go through the entire list and then never shrink L. Maybe there's another condition to shrink L, right? When should I bring L? There's gotta be another way to bring up L. Come on, bruh. I know there's a way. There's a way to bring up L. Bring up L. Oh, if it's negative, you know? No, it's fine. I don't think that makes a difference. Basically, I should keep looking until I find I should be looking, right? I should expand out until I... What if I do a second run? Like, for example, like, if L equals 0, while L, while, while nums does not equal L, nums L, right, will increase. And then let's say they do, right? If nums L nums -1, nums turn true. Well, let's see. Return ABS L, or length of nums -1 minus L. I'm so tired. Greater than or equal to K. Is that gonna fuck things up? Yeah, it didn't even make a difference. I'm missing something here, guys. What am I missing, dude? I suck at sliding window, bro. I'm trying to understand what I'm missing here. Right? Oh, okay, that's fine. Right. Okay, why? Okay, so basically have to do, okay, so go as far as you can. Nope, 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 nope. And then and then I do like somewhere here, then maybe I do a second while loop, right? While L less than length of nums, right? L, I'll increase that. But as we check, if nums, or let's say, let's do like, I guess R, like to, let's do J here, equals length of nums, right? If nums J equal nums L, return ABS of J minus L Oh, that's my problem. I'm returning way too early. And equal to 3, K, return true. Yeah. We just finish out the left point, like the left window, I guess. Will this work? Oh, but this fails. Okay. Let's see. I got true this time, but expected false. How is that possible? Why does this one fail? Let's go through the code here. So we have nope. So we go here. Started from these two. So let's check. Is 1 minus 0 greater than K? Nope. Are they equal? Nope. So no. Oh yeah, we do have an equal here. So this is 0, 1, 2, 3. So 3 minus 0 greater than K. Yes, so we increase. Right. It's now 3 minus 1 is 3 minus 1 is 2. 2 greater than, nope. So we don't increment anymore. Nums, are they equal? Nope. So we skip. Right. These equal? Yes, they well, first is L was 0, 1, 2, 3, 4. 4 and 1. 4 minus 1 is 3. 3 greater than K. Yes, we increase. Oh, that's my problem. Yeah, it doesn't really matter, to be honest, because I actually want the smallest distance possible. Then these equal? Nope. Oh yeah. So these equal. Nope. So skip. Increase. Distance too much. No. Do this here. The equal. Nope. Check here. Nope. I'm confused. Let me see. Print nums j. Print nums l. Three and three. What? What are these indexes? Five. Oh. Yeah, I gotta add this here, or and j does not equal L. Yeah. There's no point in checking. Can't be itself, you know. Oh, is that why that was true? Wait, what? How long has it been? 27 minutes. Dang, it's time for me to look at the solution. It's taking me way too long. Ooh, hash map and set. I was gonna do that. What? So we go through the nums. If the val is in scene and I minus scene val is less than or equal to k, then return true. Otherwise store it. Brother. I thought that was like a mere space efficient way to do this. I was thinking way too complicated. Hash map bar. Hash map. I have this. Right, so for every kv enumerate nums, if k in hash map and hash map in k, yes, k minus less than equal to k, or yeah, k. Oh, I shouldn't use k to be honest. Let's do I return true. Hash map I minus looking like a two-sum type of problem, right? Yeah. Oops. I don't know how to do sliding window with this though. I don't feel like this is really sliding window. Let's see a sliding window solution. Ooh, let's see. Wait, what? There was a sliding window solution. Wait, that's kind of smart. I should have used the set. I forgot that you don't need to use. Yeah, I forgot. So the window is the set, right? If k equals 0, right? Return false window set. Let me see if I can deduce it again. Right. Let's have L. Let's have for R in range of length of nums. Right. So window dot add nums of R while. Oh, I see. If nums of R in the window return true, if R minus L plus 1 greater than K, window dot remove window nums L and then L. Dude, I was so stupid. I couldn't think of this. And this is such a solid like window solution. So the window here is the set. Yes, the window here is the set. As we let's say we are in the window. And then that's fine. Let's see. So we add 1. Zero, 1 greater than, nope. I'm a bit disappointed in myself. I feel like I could have solved this. L, then remove that. So like as soon as the distance becomes big as hell, yeah, that makes sense. Yeah, we want like a really small distance. Yeah. Remove it and get rid of it. Damn, I feel like I could have solved it, but it's fine. Anyways, thanks for watching. I'll see you tomorrow. Peace.